Welcome to the Risk Assessment and Job Hazard Analysis presentation by the Motor Safety Association. So in today's presentation, we will discuss what is a risk assessment and job hazard analysis, how do I conduct a risk assessment and job hazard analysis, and hazard ID and control. You may have noticed I've abbreviated and used JHA, and that's the short form for job hazard analysis. So throughout the presentation, I will refer to job hazard analysis as JHA. So let's talk a little bit about the differences between risk assessment and job hazard analysis. These are, in fact, two different things. But sometimes people make the comparison, but in fact they are different. They think that they're very similar, but there's differences. For example, a risk assessment is a quantitative tool that we use to assess risks and hazards when we're looking at performing a job hazard analysis. We use the risk assessment as a step or as a component of the job hazard analysis. We use it to determine which jobs require a hazard analysis. And we'll show you examples of how, in fact, we can assess jobs to determine the risk level using a risk assessment matrix. So let's talk a bit about the risk assessment process. It's used to identify hazards in the workplace, and we look at such functions as the probability of this event happening, the severity, how bad is the person going to be injured or hurt, and the frequency, how often is the worker doing that job or task. We look at the risk of harm from those hazards, that's through the severity, and we prioritize those occupations that require a job hazard analysis. So by going through the process, we can determine what jobs require a JHA to be completed by doing the risk assessment matrix, because we've assigned a quantitative assessment value to that job. So when it comes to ranking the hazardous tasks, keep in mind the risk assessment process is rather objective, because when I do a risk assessment, I'm basing that on my own personal experiences or my experiences to that event or my past knowledge. So my numbers, what I choose for the risk assessment, may be different than what you choose. So that's important why we like to work in a team of three when you're doing these risk assessments and coming up with values. So the results aren't just coming from the safety committee or from the safety person. That way you're getting some buy-in by talking to people and giving a bit of a process involvement with the staff by getting their input into the projected assessments for the risk assessment. So what exactly does the risk assessment matrix look like and how does it work? Well, here's a sample template that we've utilized, and you can see our top row of numbers 1 through 5. Then we have our probability. So what's the probability of this event happening? Is it rare, unlikely, possible, likely, or certain? And if it were to happen, how much of an injury would the person be exposed to? Would they require a first aid treatment, or could it be all the way death? And each of these values that we choose here reflect the number above it. And then same thing with frequency. How often are we doing that task? Monthly, weekly, daily, hourly, or constantly? So we take our probability, multiply it by our severity, and multiply that by our frequency to get the relative risk. So let's do a couple of examples together, and then I'll explain total risk after we do the couple examples first to determine our relative risk. So if I was changing concaves in a rotary combine, I would say that it is possible that I would have an injury by doing that task. If I was completing that task, the severity, I would say it would likely be a time loss injury, that I was injured severe enough to miss time from work. But how often am I changing concaves in the dealership? Well, I would say in this example, once a week. So I would take 3 times 3 times 2, and that would give me a relative risk of 18. But what if I was doing a different task? Let's say I'm changing knife sections on a cutter bar. Well, the probability of me being injured is a 4, because knife sections are very sharp, and I'm working amongst the guards, kind of in a confined area, and guards are pointy and sharp as well. What about the severity? In that situation, it'd be a 1 first aid, because a couple Band-Aids and we'd probably be able to would be all the medical treatment that we would need in a situation like this. But the frequency, how often am I changing sections at our dealership? Well, I'm doing a cutter bar once a week. So I would take 4 times 1 times 2, and that would give me a relative risk of 8. So at first glance, it appears that changing concaves in a rotary combine would pose a higher risk than changing sections on the cutter bar of a mortar conditioner. But let's look at it a little bit closer to determine total risk. Now, if I multiply my relative risk by the number of employees at risk, and if I have 3 people changing knife sections on the cutter bar, so I take that 8 score on my relative risk, times it by 3, I now have a total risk of 24, which is a higher risk than the example for changing concaves in the rotary combine. So this gives you a different way of looking at data and determining, by looking at the probability, severity, and frequency, what the chances or the risk involved of somebody being involved in an injury. And it allows you to look at how many people are doing that task. The more people that are doing it, even if something poses less probability and severity, or the frequency numbers are lower, the results may be higher total risk depending on how many employees are doing that task. So in those situations, you may want to concentrate on areas that are affecting more people, that have a smaller number relative risk, or you may want to focus on those opportunities where there's a very high probability and the relative risk, in fact, is higher. So it gives you basically a tool that you can use to assess risk. And we use this as a stepping stone in conducting our job hazard analysis, because we can look at those jobs, we can assess those jobs and put a value on them, then we can determine if, in fact, where to start with our job hazard analysis. And I'll get into examples of doing that here shortly. So this is one example of a risk assessment matrix. How about this? I do apologize, this slide is a little bit blurry, but you can look up on the internet Risk X Calculator, and you will see a chart like this. And this is a great tool that we've used. This one here, it's a very similar risk assessment tool, but how it works is you take your mouse and you slide these little dots up and down, and then basically it graphs it on the side here, gives you the risk level, and it tells you, for example, medium risk or high risk. So it allows you to do that risk assessment process quite easily, and you can print it to prove due diligence. You can save it as a file name. You can save it changing concaves and combine, and again, you will have that record. So keep in mind that the drawback of doing this, however, is, in fact, say if there's one person doing it, it's just going to basically be their opinion based on their experiences. So, but it is good to get that other team involvement when you're doing those risk assessments. So this is an example of another tool that you can use to do that. How about a risk assessment app? There is an app that you can download on your smartphone that allows you, with your touch screen, to slide it over to the likelihood of the injury, the consequence, and then it'll tell you what the results are. In this situation, the highest management decision is required urgently. So this is another example of a risk assessment tool that you can use right in the field level that you can use on your smartphone to do the assessment. So let's tackle into the job hazard analysis. As I mentioned, I referred to it in the presentation as JHA, but you may have also heard it referred to as JSA, and some people call it job safety analysis. Neither example is right or wrong. They're both in fact the same thing. It's just a different terminology that you may have in fact been exposed to. But for the sake of the presentation, I refer to it as JHA. So the JHA is truly a systematic approach. It allows you to evaluate hazards each step along the way to eliminate and control or reduce injury. So it offers a step-by-step approach to recognize hazards, assess and control these hazards, and monitor the effectiveness of these controls. And this, in fact, will truly help to eliminate or reduce risks of hazards to protect our workers from injury or illness. So why do we conduct a job hazard analysis? Well, a job hazard analysis, it can prevent a work-related death or injury because proactively we are eliminating or controlling those hazards and identifying them before someone's injured. So just think of that. If we can prevent that injury from happening by looking at the job ahead of time, determining what the risks are and how we can control that, well, there we go. We've looked at an example of why we should conduct it, because we can prevent that injury from occurring by addressing the hazard at the root cause. So in some situations, our findings when we are controlling these hazards may in fact be that the workers may require more training. Maybe it's equipment that they need to do their job safely. So those are some of the things that that you could find as controls when you're doing your job hazard analysis. So what I'm going to do is I'm going to briefly just touch on these points on how I conduct a job hazard analysis. Then I'm going to show you what 2 completed job hazard analyses look like. Then I'm going to go through and explain each of these points in more detail to explain how we get them to look to that completed job hazard analysis and those steps in the process. So let's go with this process. So as mentioned, we want to identify the task or job to be analyzed, and we can use our risk assessment to determine which jobs to start with and what jobs to analyze. Then we're going to look at those jobs or tasks and break them into key components. Look at the hazards found in each component, what hazards are present that the worker is exposed to. We're going to look at ways to eliminate or control or reduce these hazards. Once we have that in place, we're going to keep a record of these hazards identified and the steps we've taken to eliminate or control them. So we're going to document our JHA. And then once it's done, we're going to come back to that. And we're going to assess and review that JHA to ensure it's working correctly. But the good thing, once we're done that job hazard analysis, we now have all the ingredients we need to develop a safe work procedure, because we've looked at all the steps in the process of how to do the job safely. So that's one positive thing that comes out of the job hazard analysis as well. Once we look at those controls, we have the opportunity to develop that safe work procedure. So here's an example of a JHA for lifting heavy objects. For the sake of this slide, we removed some information on the JHA just so that it's not too busy for the slide, and I'm just keeping it as basic as possible for this presentation. But there are examples of JHAs where there's spots where you put the date on, the signature of the people that are involved with the job hazard analysis, and various other information. But for the sake of this presentation, we've just reduced that information for the sake of the slides. So for example, lifting heavy objects, such as moving boxes onto pallets, some of the hazards present could be trying to lift too heavy of an object, bending over at the waist when turning, or while you're turning and twisting your back while lifting. So those are some hazards associated with moving those boxes onto pallets. But you remember that risk assessment process that we spoke about? Well, this is where this comes into play, and we can use that right here along for each of these hazards. So we rank each of those hazards with our risk assessment, and then we put a priority rating on it. Is it an A, B, or C, or in some situations a D? You can rank it however you want with other system you want, as long as you prioritize it so that you know which items you're going to implement first, and you have a risk assessment to look at, to utilize, to show that you have looked at that process of risk assessment when you developed your job hazard analysis. So that's why we rank and prioritize. And then we look at the controls. So for this example, it could be training workers in proper lifting techniques, to use proper lifting practices, bending at the knees and without twisting, and for heavy objects to use a mechanical device or get another person to help you. So those are some controls just for lifting heavy objects. And as mentioned, remember you can take that information and use it into building a procedure for perhaps lifting heavy objects. So let's look at another example for ladder usage. So if I was in the parts department accessing shelving, I could be using a ladder or a stepping stool, or in some situations I've seen people scale the front of the parts bins and damage the shelving, which we don't want to do as well. But let's look at some of the hazards when we are accessing shelving. So for example, the ladder may not be on a level surface. The ladder could be on soft ground. Workers reaching out too far. The ladder not high enough to reach up safely. Or the ladder may be broken or damaged. As again, we look at that risk assessment matrix, we determine the risk level, we rank it, and then we put some controls into place, such as ladder training. When people are using the ladder, not to reach with their belt buckle past the rails of the ladder, not standing on the top step of the ladder. Could be an inspection process to inspect or replace or repair your ladders if you're trained to do so. Or my favorite, use a rolling staircase system to eliminate the usage of ladders. So a rolling staircase would be your safest bet. So this gives you an example, as I mentioned, for ladder usage when we look at the risks, the hazards, prioritizing it, and the controls. And as mentioned, keep in mind you can use that to develop a safe work procedure for ladder usage. So now that we've talked about what a JHA is, why we need them, what they look like, I'm going to touch on each of those points about how we complete the JHA and give us some examples. It can be tricky and when we're looking to identify jobs for analysis, where do I start? It can be quite a cumbersome task to choose which areas to start from. As mentioned, a good example would be using the risk assessment. When we talked about the risk assessment calculator, you can use that risk assessment to determine which jobs require analysis. So that gives you one spot to look at where to start. Or I think about my time in parts management and inventory control, when we look at 80% of part sales coming from about 20% of your part numbers. The same holds true with this example. You get 80% of your results from 20% of your efforts. So if you concentrate on those 20% where in fact you've had injuries or near misses, or the potential has been there for a catastrophic event, if one human error would have been done differently, the results could have been catastrophic. Say for example, this person cutting with this lawn tractor cutting hedges, one catastrophic event from the crane operator or this operator could be quite serious. Obviously, this isn't the correct way to perform this task. So other places you could look at for analyzing those jobs could be your accident or incident reports, investigations that you've completed at your location if in fact you've had an injury, or if you investigated a near miss, property damages. What about Workers' Compensation Board claims? If you had a WCB claim, then the event already happened. So this tells you if it happened once, there's the great potential that it could happen again. So there's an opportunity to do a job hazard analysis on some of the areas, in fact, where you've experienced WCB claims. Or you can contact us in Saskatchewan for industry or trade data that we can help you with as well to determine a spot for you to start with your job hazard analysis. Next step would be walking around and talking to workers. When you do this step, tell the workers you're watching the steps in the job. You're not evaluating the worker's skill or the worker's productivity. You're looking at the steps in the process. And ask the workers, ask them, what are some hazards with this job that you do? And this is so important to speak to the workers because you're getting their involvement. Nobody knows how to do that job better than the workers performing it. So when they're doing that job and they talk to you, give you that input about the hazards, you can utilize that information to build a JHA. So when you bring that back to them, you're going to be way more successful with implementation, having people buy in to using that JHA because the workers were involved in the process, opposed to someone sitting in their office completing the JHA and telling that worker, this is how you're supposed to do your job. So sometimes that approach doesn't work very well. So talk to the workers, find out what the hazards are, and ask them too, is this job typical? Is what you're doing, has there been a change in the process? Get as much information as you can to develop and collect that data. Because the workers can really identify the hazards, and they can definitely help as well with the controls through that process when we look at completing the job hazard analysis. So once we've done that, we can break the job down into key components. Generally, it's good to limit the number of components to 10 or less. If you have too much detail, the JHA becomes cumbersome. It's quite long, but too little may omit some of the hazards, or you may miss it. So just be aware of that, so you utilize the correct amount of components so that we have an overall sense of the job, so that by someone reading it, they would have a good understanding of the process involved in when we break the job into key components. The next step would be hazard awareness. People may tolerate hazards, but that doesn't mean it's controlled. For example, young workers, they seem to tolerate higher risks than older workers. Or sometimes we'll go into a dealership and we'll hear people say, I've been doing it 20 years this way and nothing has ever happened before. Well, to me that doesn't mean that a hazard doesn't exist. It just means that they've been lucky. So when you're conducting the job hazard analysis, look at those jobs closely. And you may need to look at things differently from a fresh set of eyes and a different approach. Have an open mind when you're looking at these steps, when you're looking at hazard awareness. But also look at, for example, new pieces of equipment. If a new piece of equipment comes into the dealership and we're doing a PDI on it, where we're doing a pre-delivery inspection, we want to look at it. What if there are some new hazards involved on this new model that replace the previous model that there may not be a process in place for? So take a look at that. Be very open-minded to the potential of hazards, and take the blinders off when you're doing this step, and just to take the time to do it properly. So what types of hazards could I be looking for when I'm trying to looking at my awareness of hazards? Well, I'll run through a few examples in this here scenario of examples. What about biological hazards? Bacteria, viruses, blood-borne pathogens, fungus, mold. What if a customer brings a combine into a dealership and there's a family of deer mice in? They could have hantavirus, or what if there's grain in there that's been sitting out in the rain that could be moldy? Those could be examples of biological hazards. What about physical hazards, such as the noise levels? How much noise? What is that worker exposed to? The decibel level. Or vibration. Our association, we teamed up on a study where we measured vibration levels and impact wrenches, and we looked at we recognized the hazard of the vibration and the control of using a zorbothane wrap to wrap that impact wrench to reduce the vibration level that the worker is exposed to. So that's an example of a hazard and a control. What about the light? Is lighting an issue? Is it too dark that the worker can't see? What about the temperature? Then there's chemical hazards. Gases, vapors, dusts, solvents, smokes, fumes, and mists. What if a customer brings a sprayer into their dealership and the sprayer has chemicals in it? Well, how can we repair that sprayer if we don't know what chemicals in it? We know that there's chemical hazard. What if it's lorspan or a chemical product or an insecticide that we are not aware of how to handle that at our dealership? So be aware of chemical hazards. Then there's ergonomic hazards, a repetitive motion, posture of the worker, excessive force. You could refer onto our website under our YouTube account where we've done a presentation on ergonomic hazards in agricultural dealerships for further information on ergonomic hazards. Then there are psychosocial hazards, such as stress, shift work, fatigue, harassment. Those all play a role in that category. Then there's some standard generic safety hazards that probably most commonly come to mind when we're thinking about hazards, such as housekeeping, falls, pinch points, sharp edges, moving machinery, fires, explosions, etc. So take a look. Those are many possibilities of examples that we could be exposed to for types of hazards. When you're doing your job hazard analysis, look deeper. A lot of people just stop with the physical hazards or the safety, some of these standard safety generic hazards. But think about biological, chemical, and ergonomic and psychosocial hazards when you're performing your job hazard analysis. Now that we've looked at and identified those hazards, how do we eliminate or control those hazards? The best way is always to eliminate that hazard right at the source. If we can eliminate it so that the worker is not exposed to it, that's our ultimate goal. If that may not be possible, we may have to use engineering controls, such as barriers or shieldings of some sort, or administrative controls, perhaps training or safe work policies or procedures. So those are the preferred methods that we like to use. But unfortunately, a lot of people, they start with personal protective equipment because in some cases it may be the easiest or the quickest fix. But what does that do to address the main problem at the source? That hazard is still present right at the source, and we may not have done something to address it at the source, to eliminate it, or to use an engineering control to reduce the worker's exposure to that. But unfortunately, we sometimes look for the easy way and give our workers maybe safety glasses or hearing protection and just hope for the best. But in fact, that is probably the worst thing you can do because that hazard is still present. What about the example, if I'm running an air compressor in my dealership right in the next bay where my technician's working, and he's exposed to 90 decibels on and off consistently through the day, well, that's going to cause some hearing damage. So the best thing we can do right at the source is to replace that air compressor with a quieter model. If that may not be in the budget, something else we could do is maybe along the path. We could reduce the worker's exposure along the path, whether it be enclosing that air compressor in a room or a sound barrier curtain of some sort to control the worker's exposure to that direct noise. Then the least affected would be giving the worker some hearing protection. So you can see by that example why it's best to work with the hazard right at the source. And here's an example of just a bit of a diagram. So if I'm working with that sprayer that a customer brought in, and I'm not sure what sort of chemicals in there, I'm not just going to wear gloves and goggles and coveralls, but I don't know what I'm working with. What if the best thing we could do is eliminate that hazard and we'd have the customer drain that sprayer in a safe environmental fashion, or ensure that our workers aren't exposed to that hazard by either eliminating it right at the source. And there's the examples of engineering controls. What if some situations it's not practical or feasible to eliminate it? In this machine, we need this belt drive to run this piece of equipment. So the best way to do that is, obviously we can't get rid of it because we need that machine to do its job. Let's put a guard or a shield on that belt. That'll be an engineering control to prevent the worker's exposure to the hazard. Another example of a control that is in place that you can use is basically eliminating the hazard on the job is having that work contracted out. What if, and I'll use an example of a dealership I was at recently where the light fixtures needed replacement. The service manager said, I'm not going to send my technician up on the ladder to change these light fixtures. For one, he's not an electrician, so he hasn't had the proper training on how to do it. We don't have the appropriate lift with the man basket. nor has my worker had the training for a fall arrest, and he isn't fitted for a fall arrest harness. So those are some major reasons why we cannot send our worker up there to change the light fixture if he's not trained and has the proper equipment to do that task. So there's an example of right at the source eliminating the worker's exposure to something that they may not be trained to do. Here's a bit of a diagram around that noise control example. So if we move that air compressor to an isolated area, perhaps in the basement, you can see this worker is working over here, and there's some sound absorption curtains, or in this control room to keep the noise levels down. So I challenge you to think about this in your location or store, and think about different examples that you have of hazards in noise or various other examples and how you can control them. What about equipment lockout, tagout? And a problem that we come across with, what about in farm machinery? A lot of times the ignition key is the same key fits all for a lot of pieces of equipment. And we may have a technician working in the engine compartment on a combine, maybe changing a fan belt, and another technician jumps in to start the combine to move it. Well, it's not going to be a good day for either of those people involved in that accident. So we have to take a close look at controlling this right at the source and implementing a lockout tagout procedure. For example, maybe we need to have some signage on the cab of that combine, or a sign on the steering wheel, something like that that we could look at as far as equipment lockout tagout to prevent that from happening. So this is quite a critical area that sometimes gets overlooked. But when we are controlling various steps in our job hazard analysis, this is something that we could definitely look at and take a very close look at how we can address that. And lockout tagout is this process that works quite well. Then we get into the administrative controls, and that could be that I spoke of earlier. It could be the training, the way the worker is trained on how to do that job, or it could be through safe work practices or procedures. So the administrative control, it acts on the worker, not the hazard. The hazard is still there, but the worker avoids the hazard by the way they do their job. So by various training or safe work procedures, etc., through safety toolbox talks or meetings, they could have examples of administrative controls of learning how to do that job safely. What about signage? There's an example of administrative control. So administrative controls, they also look at the amount of time workers exposed to a hazard or the number of workers that could be exposed to that specific work practice. So keep that in mind as well. And the last method of controlling hazards is through personal protective equipment. And as I mentioned, that is the last method. This should be considered only after other methods have been tried and shown not to be feasible. And this still requires an understanding of how to use PPE correctly. We see too many times when people have foam earplugs that are sticking out way past their ears. They didn't roll them and stretch the top of their ear to insert those earplugs properly. So there are limitations to personal protective equipment. What if I'm wearing those steel toe boots and a heavy object fell on the laces on the top of my foot? I would still be exposed to a workplace injury on my feet. What about that respirator? What are those cartridges for? Have I been fit tested? Will that fit my face? How do I store that respirator and maintain it? Do I leave it on the workbench when it's not in use? Or do I seal it in a sealed bag of some sort? So as you can see, personal protective equipment has its limitations. People have to know how to utilize it. They have to be trained on how to use it, or they can get replacements. What if they lose their safety glasses? Where do I get more of it from, personal protective equipment from? Those are things that we have to understand when we're looking at PPE, how to store it and maintain it, how to wear it properly, and where I can get more of it. And as mentioned, this is the last line of defense for the worker. If we can look at it ahead of time, whether we can eliminate it, engineer it, or administratively control it, that's our ultimate goal. In some situations, this may not be possible. we may be looking at a combination of controls. What about this worker? He's wearing a respirator and coveralls in a ventilated spray booth. So he's not just chancing it on for ventilation at those filters in the paint booth for an air supply. He's not just relying on one method of air. So for example, what if one of these things failed? No single control of PPE is 100% effective. Any one of these controls may fail at any given time due to improper design or inadequate installation. So what if those filters in the paint booth haven't been changed for a very long time and are dirty? What if those cartridges aren't inserted properly on the mask, or if they're not working properly? So we have to look at all those different controls and to ensure and be aware that sometimes a combination of controls are required for secondary protection in the event of the primary barrier failing. So lastly, once we've went through the complete process, we get to the very last step where we've developed, the potential is there now that we can develop our procedure because we looked at our hazards, we've looked at our controls. But once we've completed that JHA, we're not just going to stick it in the filing cabinet and never refer to it again. Some places, they've put it on their intranet, so on their internal dealer personnel website where staff can access that JHA at any time. So that's a great example of someone, they went through the work, they've developed that JHA, now they're making it available and allowing workers to access that information, because that's what we want. We put this information there. We want people to utilize it. We want them to know what the hazards are and how it can be controlled. And then, as mentioned, this gives us a prime opportunity to develop a safe work procedure based on the results of our job hazard analysis. So anytime, once you've done your job hazard analysis, once it's done, you may have to review it. It's not done indefinitely. What if that piece of equipment has changed, or if there's significant changes in that process? So that's why JHAs require us to go back at and look at to ensure that they are effective, still working properly, and if anything has changed, we can make those changes and implement the necessary controls. So to summarize, the steps involved are we look at the inventory of occupations or jobs. We've identified those job tasks and broken them into tasks or components. We've looked at those risks, prioritize those job risks using our risk assessment. We've looked at various risk assessment tools that you can use, whether it be a RiskX calculator, an app, or a more traditional matrix. We've taken that information, we've compiled and conducted our job hazard analysis, and we reevaluated that procedure. We've looked at the job hazard analysis. We've followed up to ensure it's done properly, the controls are in place, and it's accessible to our staff. So that's kind of an overall view of the summary steps of completing that job hazard analysis. For further information, you could contact us at our websites on the bottom left corner of this slide, where we have available job hazard analysis pocketbooks. And these pocketbooks work great. It allows technicians to slide these right into their coveralls. It allows them to identify breaking the tasks into steps. What are the hazards? What are the controls? They can make some notes in that book. They can signature it. They can date it. All of that equals due diligence. We have an example of a job hazard analysis right in the technician's pocket that they can bring into the safety committee, the service manager, and we can use that information to build a JHA. But there's an example of how we can collect that information. That's how easy it is. We also offer a supervisor fundamental workshop in Saskatchewan, which gives more information on supervisor responsibilities as well as risk assessment and job hazard analysis. Or you could also refer to the Canadian Centre of Occupational Health and Safety's website for more information. Or if you are in Saskatchewan, we can come out and help you as well with this task. If you are a member of our safety association, we can get you started on helping and assisting you to perform those job hazard analysis. With that, I'd like to thank you for taking the time to join me and listen to our presentation on risk assessment and job hazard analysis. We've got a great website, motorsafety.ca, that you can refer to for more information of things we've been working on, different case studies and upcoming training, and various other sample templates that we have available, as well as our contact number if you require further information. With that, I thank you very much.